This is Daniel Bacon-Brown at Moxtek Incorporated. Today I'd like to show you how to use the Moxtek Process Design Kit, or PDK, in PlanOpSim. We'll be designing a visible wavelength meta lens using Moxtek's proven meta-atom libraries. You can follow this method to design your own meta lenses with the assurance that Moxtek can fabricate it. First, let's take a look at the Moxtek PDK. Go to the PlanOpSim web app, go to Library, and choose Meta Cell Groups. This contains a meta cell group called Moxtek PDK 532v0.7. This is a Moxtek meta cell group designed for the PDK at 532.0 nanometers. It is version 0.7. This is the best version, but this may change as we are constantly improving our capabilities. So to make a meta component, I'm going to go to the meta component section, click a component group, and click the plus. Now the first thing I'm going to do is change the component dimensions. Let's change it to, say, 50 microns by 50 microns. That will speed up the design time and keep this video short. So we need to choose what meta cells are selected in the design. So we go to the Component Selected Meta Cells section, click Edit, and under Meta Cell Group, click and select the group that I was talking about earlier. Now it asks you to read the instructions. I've already read them, but you should do so when you get a chance. Now you want to click the button at the top. This will select all of the cells in the library. Move it to the right and click the check mark. And so now all of the meta cells that are in the library will be available for the design. Now we need to design what the lens is supposed to do. Let's go to Target, and there aren't any targets now, so I'm going to add a new one with the plus button. Now today we're going to define the wavefront. So you scroll down to Near Field Wavefront and you click the paintbrush. So this is where you can define the wavefront in code. There are a lot of built-in lens designs. I'm going to choose the aspheric lens designs today. And the only thing I'm going to change is the wavelength. Change that to 532 nanometers, or 0.532 microns. We click Generate and wait for this target profile to be generated. Sometimes you have to wait in the queue for a little while because someone else is using the servers. Okay, so it has generated the target wavefront, the amplitude, and the phase profile. This looks good. So let's actually make the design. Go to the Design tab, click Start Design. And in a moment, the PlanOpSim servers will process the design request. While we wait, let me say that while this meta-atom library is just for 532 nanometers, we also have capability for a broad spectrum of wavelengths. We've made meta lenses from 405 nanometers to 1550 nanometer wavelengths. If you'd like to design a meta surface in PlanOpSim, but don't find a PDK for the wavelength that you want, let us know and we can develop a meta-atom library PDK for that wavelength. While we wait, let me talk a bit about our metalens design capability, our metalens manufacturing capabilities here at Moxtek. We are based in Utah and have been an optics manufacturer for over 35 years. In recent years, we've broadened our capabilities to the manufacture of visible and near-IR wavelength metalenses. We do not only small volumes for testing and R&D purposes, but we also do large-scale production with capacities of up to hundreds of thousands of 8-inch wafers per year. We have in-house metalens metrology and can measure 100% of produced metal lenses. For more information, you can visit moxtek.com. You can send me an email at dbaconbrown@moxtek.com. That's DBACONBROWN. Or you can call us at 1-800-758-3110. And now we wait for the designs to process. Looks like it's processing now. And in a few moments, we should have the design. And the design is complete. Now, because this is a PDK design, the design details are hidden from the user. So this mask file will not be accurate in this case. Instead, what you can do is click Report. This report contains all of the settings as well as the generated field and amplitude of the wavefront of the meta surface. And now let's open this and we can compare the generated wavefront to what was targeted. Okay, it's opened up in a new tab. Let's look at, these are the meta atom. This is actually a dummy meta atom library. The actual meta atoms are hidden. So here are the target amplitude and phase profiles, as well as the result amplitude and phase profiles, what is actually used in the meta lens. And I think these look good. So if I want to actually make those meta lenses, what I'd do is I'd go to Request Fabrication. And let's say I want 100 pieces. I type in my email. I choose what time that I need to have it. And I enter any extra information. And then click Ask for a quotation. So what this does is it sends the request, the design that you want to make to us, and then we can provide you a quote. And then we can from the quote we can move on from there. If you like the quote or you don't, we can decide that. So that is all I have for you today. Thank you.